Okay, here's where we left off, and I do have some stuff already written down from last period, but we said that power, my weight in newtons is 948 newtons, right? We already went over that. And then if I multiply that by the height of the steps, if I went from here and ran up to here and divide that by my time, I could figure out how powerful I am. So let's figure out the height of the steps. Now these are the calculations that fourth period got, all right? So they measured about 17 centimeters per step, is that right? And you guys counted 24 steps? And I heard one of you outside say it was about 4 meters, and you can use 4 meters. They got 4.08 meters, which is probably beyond the precision of our measuring. 4 meters is probably good enough, or 4.1 or something. But anyway, so I'm just going to use the 4.08 meters. So this is how high we went. Now, my time this morning during fourth period was a little faster than this afternoon, maybe a little tired. Actually, what I did at lunch is I walked to the stadium. I'm trying to get into shape because Mr. Kinney and I are going to go on this big hike, right? So I'm trying to get into shape. So at lunch, I walked to the stadium and I went up and down the steps in the stadium. So I think I'm a little tired from doing that. And so I wasn't quite as fast. But this morning, I ran up the steps in 7.45 seconds. So if you figure out how much work I did going up the steps, 348 newtons, multiply that by the height, this gives me the gravitational potential energy that I added to my body by running up the stairs. Divide that by the time, and I did work at a rate of 519 watts. Now here's what's kind of funny. I've been doing this lab since 1994, the first year I taught physics here. And this is the last time I'll ever teach this lab. When I was a young guy, my power was about, I think it was like 750 watts. And every year, I've seen my power decline. Every year, I'm a little slower. But I am a little heavier. It's kind of made up for it. Because I was very light. I was like 180 pounds when I first started teaching here. I was really thin and very good shape. I was running cross country. I was assistant coach for cross country, and I was running on my own, and I was riding my bike to school, and so I was in really great shape, much lighter, and I could get up those steps really quick, like 5 seconds, but now I can't do that anymore. So, oh well. But you can figure out what your wattage is, and I don't know, 500 watts. It's not great. I think the highest wattage I've ever gotten, I think I said was 1,700 watts. Some kid did that a few years ago. So go ahead and figure out what your wattage is. And I just expect to see this work on there. You don't really need to... I would like you to write a summary of the essential question. Okay? So make sure you do that. And now I want to go over the worksheet with you that I just handed out. If I can find it. Where did I put it? Okay. Can you hand me your worksheet? I just piled mine in it. Okay, misplaced it. So this part right here, we've already done this top part. So don't worry too much about it. We've already done all this. But these problems are going to be challenging. And I want to tell you that this is going to be the most depressing physics assignment of the year. Because, see this donut right here. I looked it up online. I Googled, like, what is a typical calorie count for a donut? 300 food calories in a donut. Now, a typical diet where you're going to stay, nice and lean or whatever is about 2,000 calories. Of course, depends on the person and their level of activity. But So 300 out of 2,000, that's a significant fraction. So if you eat a whole box of donuts, oh my gosh. So now here's the sad thing right here. If you look right here in problem 1, and I'll zoom in a little bit, but you have the worksheet in front of you. So 1 food calorie is equal to 4,200 joules. 1 food calorie is 4,200 joules. Now, how many joules did it take for me to climb those stairs? Well, let's see. I go 948 times 4.08, and I get roughly 3,800. 3,800 calories for me to run up those stairs. 3,800. How many? In 1 food calorie is over 4,000. I'm going to have to run up those steps. How many times? 300, over 350 times. I got to run up those steps to give myself as much gravitational potential energy as I got in that donut. Now, that sounds really awful, and it is. However, there is one big advantage. Humans are very inefficient. Most of the energy that you consumed while walking up those stairs was not turned into gravitational potential energy. It was turned into heat, right? Your muscles get hot. You breathe. Your body gets warm. And that's because your muscles, when they contract and then relax and contract and relax, they produce a lot of heat that has to be radiated into the environment. And then you sweat or whatever. So it's not as, you can basically take however high you would have to, whatever height you would have to march up to burn off that donut, you can actually take that and divide it by about 4. And that's how high you would really have to go. But it's still really, really high. So that's what I want you to do. Take how many joules are stored in the donut. So you just have to take 300 and multiply by 4,200 joules. How high above the ground would a 60 kilogram person have to be to have the same gravitational potential energy as the food energy stored in the donut? So if you could, how high would the 60 kilogram, most of you weigh about 60 kilograms or have a mass of about 60 kilograms. So how high would this person have to be to have the same gravitational potential energy as the food energy in one donut? It's really up there. I think it's like, it's almost a mile or something. It's crazy. Okay, and then it says the good news, your body actually transfers most of the donut energy into heating the environment, so you really don't need to climb that high to burn off the donut. But you're still going to have to burn, you have to climb really, really high to burn off that donut, which is why it's so hard to lose weight. Now, when I was your age, I tried to gain weight. I couldn't gain weight. I'd eat all kinds of food. I had a very high metabolism, and I exercised a lot, and I couldn't gain weight. Well, then I hit 30, and your metabolism just comes to a screeching halt, and then, ended up gaining, quite a bit of weight. And it wasn't muscle. Okay. Now, what power in watts does our donut eater give off if it takes an hour of fast walking to burn off the calories in the donut? So if you don't want to, so let's say you want to burn off the energy in 1 hour. How many watts are you going to have to walk? And I looked it up. These are pretty reasonable numbers. For an average person to burn off that donut by walking, they'd have to walk for an hour to give off more than they would if they just sat in front of the TV and ate another donut. All right. And this problem 3 is pretty interesting. To lose 1 pound of body fat, a person must burn 3,500 food calories, more than they consume. So now you got to take that and multiply that by 4,200 to get it into joules. Suppose a person wants to walk off a pound every week. let's say you want to lose weight, you want you want to lose a pound a week. How much would you have to walk every day for that walking to be the difference? You want to do just exercise to lose a pound a week. How long would you have to walk? And then number 4, using your data, determine how many flights of stairs you would have to climb to burn off that donut. So these are all kind of related to what we just did. And number 4 depends on you, depends on what your power is. Now you can take this value you got in number 4 and kind of divide it by 4 to get a more realistic idea of how many flights of stairs you'd have to march up to get rid of that donut. And by the way, I enjoy donuts very much, but these things are like, it's like the crack cocaine of food, all right? It has no nutritional value. All it does is give you calories, and they're the worst kind of calories. And so I don't like it when people bring donuts to work, because I end up eating them, and I don't want to eat them. All right, so maybe I should learn more self-control, but that's really not. So I'm going to go for a walk, and that is all.